Hey there, math fans. Continuing our little discussion of Intro to 3D. The moment you have the distance formula, you also have the equation for the sphere. Why is that? It's the same thing as in 2D. If you fix a point in space, let's call it the center, and you attach a string to it and start labeling all the points, and those of you that have ever had to draw a circle or draw something on a baseball field, you know you've had to do this before. All the points that are the same distance from a given point, that's the worst circle ever, but we're going with it, is a circle. Now, if you extend that idea to 3D and you allow the string to move around in 3D, but have this fixed distance, which we usually call R, you get a sphere. And when we're talking about the sphere, we're just talking about the points on the edge, because those are the points that are that distance. So the equation for a sphere is exactly this. You put the center here, you put the radius here, and you let the other points vary. So if you never realize that, that's exactly where the equation of a circle comes from. This is no different. It's the same distance definition. So we say the square root. We say, let's have x, y, and z be the points on the edge of the sphere. So this really forces you to think once again about your 2D conditions. Now, the example I have on the right, the points they gave me are 1, this is from a homework question, negative 12, and 8. The radius they gave me was 10. That's that purple sphere you're seeing over there. Now, normally we don't write it that way because it's not very pretty, so we square both sides. So we say 10 squared, the radius squared, is x minus 1 squared, y plus 12 squared. And so what's nice is it doesn't take much to get us here. And we already are able to talk about a surface in 3D. Again, that describes points on the edge of that sphere. So let's talk about it a little bit and play this game of what we can say about it. So one of the first questions we can say is, what about intersections? What can we say about various intersections with that sphere? You can see that it hits the ground. You can also see it hits one of the other planes. So what is the ground? What are the conditions for being on the ground? And so this is where I sit down with students and I say, well, what does it mean to have a point x, y, z that's on this sphere and on the xy plane? Think in terms of conditions. The condition is that this has to be 0. So even though we're in 3D, it doesn't change what you had to do in 2D. Part of the problem is people don't understand in 2D what you're doing. But even if you have that, it's okay. The idea is to combine conditions. That's what you've been doing your whole life when you find the intersection of two lines or a circle and a line. We're just doing the same thing. We have these two conditions. We combine them. What do you get? And you should see what you get. You get 10 squared equals x minus 1 squared, y plus 12 squared. And I like this. It's a real nice how quickly we can get to something fairly valuable here. And what is that? This is 100 equals x minus, this should be starting to ring some bells. It should look familiar. If not, that's fine. We move it to the other side. We get 36 is equal to x minus 1 squared. You should recognize that as something you might have seen in 2D. It's a circle centered at 1, negative 12 of radius 6. That's not a surprise to me when I look at it. It looks like the intersection is a circle. Let me show you some things. There's that plane. There's that intersection. Let's get rid of the sphere so we can see it. So I feel like for a lot of students, that's like an aha moment of, oh, this is valuable. Absolutely, it's valuable. That's that intersection. Now, throughout this course, we're going to talk about other intersections we can get. What about if we go up or down? Well, if we go down, there's no intersection. Well, a little bit there. Let's get it off there. Then it goes up. Oh, man, look at that. I think that's pretty cool. That's stuff we're going to be doing. We didn't really need to see a picture to that. In fact, if I didn't have the picture at all, I still would have known it's a circle. That's what the students don't get. That's how I used to teach the course. I was like, we don't need that. What we just did tells us it's a circle. So to me, the bigger thing is learning how we don't need to visualize it. But I've realized recently that the visuals bring things to life for students. And so I don't want to deprive you of that. If this really makes you like it better, great. When I was a student, I was like, oh, I could see the interest, but I realize now that I need to sell it a little more. So then you can ask the natural question, what are some of the other intersections you can get? And now you start to understand this idea of conditions. All this is a condition, what it means to be 10 units from that center. We need to combine it with other conditions if we want to ask questions. So what does it mean to hit? Oh, how about, and then you should start asking questions yourself. Is it going to hit the YZ plane? Yeah, you can see it runs right through it. What would the YZ plane be? Well, that would mean X is 0. Okay, so let's make X 0. Here's X. Oops, I didn't mean to graph both. Let's get rid of that one. Here's X. Oh, it's not quite 0. It looks like I'm a little bit off. I got to change my parameter a little bit. So here's like a bunch of different X's. Let's make X exactly 0. There it is. We can see it does intersect. It's a circle. How could I figure that out? Simple. I put X equals 0 in the equation of the sphere, and it gives me a circle. Like I said, this is often kind of an aha moment for students of, oh, this might actually be worth something. Or, I'm sick of this. On to the next course. Last thing, when does it intersect the XZ plane? This one always bothers students because they're like, they go to do the homework and they type it in and the homework says, your answer's wrong. You say, I did it the exact same way. Well, what happens? Desmos 3D likes to spin things. Here we go. Oh, I'm getting dizzy. Okay, what happens? Ah, it's still spinning. Stop spinning. Okay, what happens when I replace Y with 0? This is why you have to just not blindly do things. You have to analyze a little bit. What can you say here? Well, if I plug in 0, I'm going to get 12 squared, which is 144. And that's when I start to get worried. This is 144. This is 100. If I move it to the other side, I get negative 44. That's not a very interesting circle because it's impossible to get numbers that make that work. So we would say there is no intersection. That's not just a random thing. So there's an intersection when you get to certain values. So if you found that interesting, I feel like this gives you a nice little feel for 3D, which is really the goal of the beginning of this course.